Okay, in the last class, we have seen the gate level modeling. Okay, gate level modeling examples. Okay, how to write a program HDL verilog HDL program in the gate level modeling. There are three ways to write the program for the my digital system. One is what the structural model or gate level model. Second one is the data flow model, or third one is the behavioral model. So that in the third model we are studying about the gate level modeling. So we have the consider the two examples. One is what the 4:1 MUX. Writing a program for the 4:1 MUX. 4:1 MUX. Okay, writing a verilog HDL program in the gate level modeling or structure model is we consider here the 4:1 MUX. Okay, what is the multiplexer? What is the multiplexer? What is the multiplexer? What does it mean? What is the multiplexer? What is the multiplexer? Okay, multiplexer is the one of the combination logic circuits. Okay, we have the start ಮಾಡಿದ ಕ್ಲಾಸ್ ನೀವು ಸೈಲೆಂಟ್ ಕೂತ್ರೆ ಹೇಳ್ತೀನಿ, ಇಲ್ಲ ನಾನು ಸುಮ್ಮನೆ ತಿರುಗಾಡ್ತೀನಿ. ಇಲ್ಲ ಹೆಂಗ್ ಮಾಡೋದು? ಇಲ್ಲ ನಾ ಸೆಮಿನಾರ್ ಕೊಡಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ, ನೀವೇ ಹೇಳ್ಬೇಕು ಪಾಠ. ಹೆಂಗ್ ಮಾಡ್ತೀರಿ ನೋಡಿ? ಹೆಂಗ್ ಮಾಡ್ತೀರಿ ಸುಪ್ರಿಯಾ? ಸುಮ್ ಕೂಡ್ತೀರ ಅಂದ್ರೆ ನಾ ಹೇಳ್ತೀನಿ, ಇಲ್ಲ ನೀವೇ ಹೇಳ್ರಿ ಬಂದು. ಭೂಮಿಕಾ, ಇದು ಇವು ಸುಮ್ ಕೂಡ್ತೀಯ? ನಾ ಪಾಠ ಹೇಳ್ದೆ, ಇಲ್ಲ ನೀನೇ ಹೇಳ್ತೀಯ? ಸುಮ್ ಕೂಡ್ತೀಯ? ಸೈಲೆಂಟ್ ಆಗಿ ಕೂಡ್ತೀಯ? ನೀನ್ ಹೇಳ್ತೇ, ಇಲ್ಲ ನಾನು ಹೇಳೋದು ಪಾಠ ಅಂತ? ಆಯ್ತು, ಸೈಲೆಂಟ್ ಮಾತಾಡೋದಿಲ್ಲ. ಶಿವಕುಮಾರ್ ನೀನು, ನನ್ಗೆ ಕೇಳಿಸ್ತಿದೆ ಸೌಂಡು, ಎಲ್ಲಿ ಮಾತಾಡಿ ಅಂತಲ್ಲ, ನನ್ ಕಣ್ಣಿಗೆ ಕಾಣಿಸ್ತಿದೆ. ಸುಮ್ನೆ ಕೊಡು. Okay, what is the multiplexer? Multiplexer is the combination circuit which has the multiple number of inputs and we have the only one output. Okay, this the number of inputs depends on the how many number of select lanes. Okay, these are the interlinked each other. If I have the two number of select lanes, then definitely I will have the 4 number of inputs. Okay, this means so the how many number of inputs are those to the power of n number of outputs should be the select lines should be there. If I have the 8 lines of inputs, then definitely I should have the 8 is the 8:3. That's nothing but the 2 to the power of 3 is the 3 number of select lines I will have. Okay, 8 number of inputs and the this is the power number of we will have the those number of select lines. Okay, here we considering the 4:1 multiplexer. How many? Which one? 4:1 multiplexer. 4:1 multiplexer means 4 number of inputs and they only one output. One number of only one output is there. Then the select lines will be how many? 2 to the power of 2. That's nothing but the 2. Okay, to the 2 number of select lines. Select lines are there. Select lines. So that's the here the I have the combinational circuits here the 4:1 MUX. 4:1 MUX. Depending on the what type of MUX I am using, that's the it has the multiple number of inputs. It has the multiple number of inputs. That's the, which are those? I naught, I1, I2, I3. Okay, this is the only the output, only one output. That's the output. Then the select lines are there. How many select lines here we have? Can have 2 to the power of 2. This is nothing but the 4. Two number of select lines I can have, S0 and the S1. S0 and the S1. Okay, S0 and the S1. How to design my multiplexer here? How to design this multiplexer? Okay, this is to be done based on the one equation. That's the select lines combination is there. How many select lines are there? S0, S1, S0 and S1, and the I have to have the input numbers also. I have to have the inputs also. Which are those? These I0, I1, I2, I3 are there. I0, I1, I3 are there. And also, how many? Okay, this is the how to select this one based on the we can have the 00011011. Okay, based on this combination we'll select the, for one each combination will have the one input as the output here. Which one? For the 00 select line combination will have the output combination as the input as the output. This is the I0. Similarly I1, similarly I2, similarly for this combination I3. So that we are considering that we are getting the multiple number of inputs, so that among those inputs one input has to be considered as the output here. This is mainly used in the in the telephone. Okay, if you are getting the many number of calls at the same time, it will receive the only one call. We can receive the only one call. Okay, that's the we'll be using, so that I can have the input. How many number of inputs are those? That one I can select. I have to select the only the output here. So that for this purpose, I have the select lines also. For the select lines, for the this select line combination, I can have the I0 as the output here. I0 as the output for the select line. Similarly, I1 as the select line for this one. I2 as the output for this select line combination. I3 as the for this select line combination. Okay, anyhow we have got the this two table. Based on this two table, I can write the output line. Output how to write it for the I0. For the I0 purpose, I can have the I0. For I0, I0 purpose select line combinations for the S0 bar, S1 bar, S0 bar, S1 bar. Okay. Then the for the I1 combination purpose, I can have the S0 bar and S1 is there. For the I2 select as the for the S0 and the S1 bar. Similarly, for the I3 combination, for the I3 selection purpose, I can have the output input combination. These select lines would be the I0 and the S0 and the S1, S0 and the S1. So that by this while referring this equation, this is the what the equation for the 4:1 MUX. While referring this 4:1 MUX equation, I have to design my digital design while using the basic logic gates. Which are those basic logic gates? Actually, AND gate, OR gate, and also NOT gate is there. So that AND gate, NOT gate. Okay, so that I can use the one AND gate. This is what the product form is there. Okay, with the three inputs are there, and also this is what the select second AND gate I need here with the product form here. In this also, it means here the four AND gates I need here. For the plus purpose, I need only one for the only one OR gate, only one OR gate. While referring this equation, I have to design what the my digital system. Okay, with the help of the basic logic gates, I have to design the digital system. Okay, I am writing the digital system with the while referring this equation. This is what the first AND gate. This is what the second AND gate. This is what the third AND gate. This is what the fourth AND gate. So that I can have the inputs as the I0, I1, I1, I2, and also I3 also. Okay, the output would be what are those? outputs are given as the out with the help of the one OR gate here. So that I have given the input lines and the output. Interconnection between these two lines can be given as the Y0, Y1, Y2, Y3, Y0, Y1, Y2, Y3. So that I have to send the select lines here. Select line combination, which are those? S0 and the S1 bar is there. S0, S1 bar is there. So that I can send the S0, and S1. S0 and the S1. S0 and the S1. Before the, this is the having the value as the 1. I can send the value as the after this not gate, its value would be what? The S1, S0 n, S0 n. This means what? The here it is value having the S0 as the 1. After the passing this S1 S0 value, that will become what? The 0. But I need the S0 as the 0. S0 as the 0 means I can select the pass this S0 toward the through the NOT gate here. So that I am sending this S0 to where? To first AND gate. Similarly, I need what? The one more S1 bar I need here. S1 bar means I have to send the this S1 also with the one NOT gate, because it was having the value, it is having the value as the 1 before the NOT gate. After the NOT gate, that will become what? The 0. For this purpose, I have to have the S1 as the 0. S1 as the 0. Send the S1 as the 0. S1 as the 0 means what? The S1 S1n. Okay, S1n, you have to send the S1n to a first AND gate. Similarly, I have to pass the for other combination for the this one also. I need here the S0 as the 0, S1 as the 1 here. S0 as 0 means what? The this is what the S0 is here 1. After the NOT gate, it becomes what? The 0. So that I can send the select the I can take the combination for this. This will be considered as the S0. Now the S1 I need the 1. S1 I need 1 means what? Here the S1 is 1. After the NOT gate, S1 n becomes what? The 0. So that I can pass the S1 as the here as the input for the second AND gate. Similarly, I have to have the S0 S1 1 and 0. S0 as the 1, S0 as the 1, S0 as the 1 means what? I have to take the value as the S0 from here, and the S1 as the 0. S1 as the 0 means what? The S1 is here 0. That's what the I can send the select lines from this one. Okay, for the third AND gate I need. So that the fourth AND gate is having the combination as the S0 is 1, S1 is 1. S0 as the 1, S1 as the 1 here. So that I can have the S1 means 1 means what? Before the NOT gate, I have to send the input as the input to this one, and also this one as the before the this second NOT gate, I can send the input as the 1. Okay, this was the I designed the my 4:1 MUX with the help of the basic logic gates. It's a digital system. While referring this basic logic gates, I can write the gate level model. Gate level modeling with the help of the verilog code. Okay, verilog HDL program can be written in the gate level. Gate level means how many AND gates are there, how many OR gates are there, how many NOT gates are there. You should have to identify which type of gates I am using here. If I use the XOR gate, then you can also use the name as the XOR gate. But I use only the 3 basic logic gates. While taking these names, I can write the HDL program, verilog HDL program in the gate level modeling. Gate level model structure. Gate level model ಅಂತ ಕರೀತಾರ. ಇಲ್ಲಂದ್ರ ಸ್ಟ್ರಕ್ಚರಲ್ ಮಾಡಲ್. ಸ್ಟ್ರಕ್ಚರ್ ಏನ್ ಕಾಣ್ತದ? ಇಲ್ಲಿ AND gate ಯೂಸ್ ಮಾಡೋದು. ವೈರ್ ಅದ ವೈರ್, Y0 ಅದ ವೈರ್, Y1 ಅದ ವೈರ್, ಇವೆಲ್ಲ ವೈರ್. These are what we call the inputs. This is what the output. These are called inputs. This is what the output. Interconnection between the gate to gate, we call them as the wire. We can call them as wire. But here also wire is there. You can make it say this is the S0 as the input. But after the NOT gate, NOT gate to AND gate connection is there. This one is also considered as the wire. This one is also considered as the. Before the NOT gate, we have the value as the S0. After the NOT gate, that will becomes what? The S0n. Similarly, second select lens, this is what the input as the S1. After the NOT gate, the input that wire name is what? The S1n. While referring these concepts, this concept completely, I can write the HDL verilog program. Okay. Okay, first start with always a model. Capital letter baribardu, small letter baribardu. Model. Okay, model name can be given any name. Okay, I have the 4:1 MUX, so that I can write the 4:1 MUX. 4:1 MUX baridada 4 to the power of 4 underscore 1 underscore MUX. MUX. This is name baribardu parvagilla. You can write. I start model start admala end model baribe compulsory. End model. End model, so that I have to give the send the input combinations. Okay, inputs and outputs here. List of ports, which number of how many types of ports I am using here. One is for the input port, another is the output port. First I have to send the output port list here, which how many outputs are there. One output is there, only one output. Just to write the output name as the out. Next is what the inputs are there, which are the input lines are there. And also select lines also considered as the inputs here, so that I can write the I0, I1, I2, I3, and also select lines also S0 and the S1 to be considered as the inputs. Okay, S1, S0 and the S1 to be considered as the inputs here, so that I return the port list here. I return the port list, so that I have to separate this one as the input number of ports, which are the inputs are there. Inputs which are those I0, I1, I2, I3. Even I can send separately. I can write the for the select lines as the input, so that I can also write with the here also S0 and the S1. ಆಯ್ತು, ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಔಟ್ಪುಟ್ ಬರಬೇಕು. ಔಟ್ಪುಟ್ ಲೈನ್ಸ್ ವಿಚ್ ಆರ್ ದ ಔಟ್ಪುಟ್ ಲೈನ್ಸ್ only the out one. And now I have to define the wires. How many wires are there? 1, 2, 3, 4, and also S1n, S0n and S1n, so that I can write the wire ಅಷ್ಟೇ ಬರಬೇಕಾ. ವೈರ್ ಅಂತ ವೈರ್ಸ್ ಅಂತ ಬರಿಬಾರ್ದು. ಕೀವರ್ಡ್ ಏನಿದೆ ವೈರ್ ಅಂತ ಅಷ್ಟೇ ಬರಿಬೇಕು, ವೈರ್ಸ್ ಅಂತ ಬರಿಬಾರ್ದಾ. ಓಕೆ, ದೆನ್ ಐ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ವೈರ್ ಆಸ್ ದಿ Y0, Y1, Y3, so that inputs select like these are the also wires are there. Just look at here, one gate to another gate we are connecting. This one is not the S0n, S0n, and this is the S0. S1n. Okay, then define the how many gates are there. One first AND gate, second AND gate, third AND gate, fourth AND gate. Just to write the AND gate first. So Madhu number link. AND gate, second AND gate, third AND gate, fourth AND gate, and also I need the which are the NOT gates also there. So okay, NOT gates, two NOT gates I need here. NOT gate. Just to identify the gates, which are the gates I am using here, and also I need the one more OR gate also I need here. OR gate also I need here. Okay, how many gates are there? Okay, AND gate, NOT gate, and the OR gate is there. First AND gate and barnala adukondre I can instantiated with the name, any name here. Okay, any name AND gate. Okay, then I have to write the port list here. Which are those AND gate yavada inputs? I0 first output ಬರಬೇಕು. Y0 ಅದ ಫಸ್ಟ್ ಔಟ್ಪುಟ್, Y0 ಬರೀರಿ. ನೆಕ್ಸ್ಟ್ I2 ದು Y0 ಅದ, Y1 ಅದ. I3 ದು Y2 ಅದ. I4 ದು AND gate ದು Y3 ಅದ. NOT gate ದು I to write the first outputs here. How many outputs are there? Only one output for the each gate here. For each and every gate, I have the only one output is there. Which is the what is the output name? For the first AND gate, Y0 is there. Second AND gate, Y1 is there. So that I can write similarly. Okay, that's the first AND gate output is what the Y0 input. Which are the inputs here? The I0, S0 bar, S1 is there. Which are those? I0, Y0, I0, S1 bar is there. S1 bar, N, S0 bar, n. Okay, this is what the I naught is there. This one we call as the S naught n. This is what the S1 n, S1 n. Similarly, I can write the first AND gate, second AND gate ಯಾವ್ದು I1 ಅದ, ಆಮೇಲೆ ಎರಡು ಇನ್ಪುಟ್ ಅವ, ಯಾವ್ದು ಅದ S0 n ಅದ, ನೆಕ್ಸ್ಟ್ S1 ಅಷ್ಟೇ ಅದ. Because depending on the input combination, what we have the connections here. Okay, then the I1 S0 n and the S1 only, and the S1 only. So that I can write the similarly I2 S0 n, sorry S0 ಅಷ್ಟೇ ಬರ್ತದೆ, n ಬರಲ್ಲ. ಎಲ್ಲೆಲ್ಲಿ n ಎಲ್ಲಿ ಬರ್ತದೆ ಅಂದ್ರೆ there we have the only the 0, there we can write the n, so that I can have the S1 n. Similarly, I can also write the output for the AND gate, that's the I3 S0 and the S1. Okay, this is what way we have the output inputs. Similarly, for the first NOT gate, having the input as the S0, sorry, output as the S0 n. And first NOT gate, then the output S0 n. Input another, what you have S0. Input is what the only the S0. Just to write this one also. Similarly, for the second NOT gate, this is the input is what, output is what the S1 n is there. Just to write the S1 n. Input is what there? Input is here the S1 is there. Just write the S1. Similarly, for the OR gate, here, for the OR gate, just you can give the name as the N1, N2. You have to instantiate that gate. Okay, R means O1. I am writing the output of the first OR gate. What is the output of the OR gate here? Out. Just to write the out as the okay, inputs for this OR gate. Which are those? Y0, Y1, Y2, Y3. Just to write those inputs also. Y0, Y1, Y2, Y3. This is what the writing of the, just to write the end module. Okay, this is what the writing of the program, verilog HDL program in the structural model or gate level modeling. Okay, this is the repeatedly asked, frequently asked question. So for the 10 marks, writing a designing of the digital system and the writing a verilog HDL program in the structural or gate level modeling. This is the 10 marks. Okay, we have written the program for the 4:1 marks, okay, in the verilog HDL. But I have to check this written program whether it is working properly or not. If the input combination. Okay, for testing of while verifying of my verilog HDL program with the help of for the inputs combination, that is to be written with the help of for the test bench. What we call is the test bench. Test bench always start with the no input ports there. Okay, module name will be there. Test bench as the module with the stimuli with the, there is no parameters, there is no variables, will not send port list and all. Just to write. And also we are considering the wire here as the for the inputs purpose. There this to be considered as the output there, reg. Whatever the output is there, that is to be considered as the input there as the wire. This wire and consider martivi, this reg and consider martivi while writing the stimuli, means for the simulation waveform. Okay, write the program for the stimuli module and the end module is compulsory. End module compulsory. Module barmela and end module baribe compulsory. Okay, we don't have the, we have the name for the stimuli. The program name is what? The stimuli. What is that? Stimulus. This is what the verilog, this is what the test bench for the test bench purpose. We are sending the inputs combination through this one. Okay, whatever we have the inputs over there, is this to be considered as the reg with the keyword as the reg as the There we have taken the small letters, we have to write the with the big letter as the, we have to give the input I naught, I1, I2, I3, okay. And also we have the two more are there, two more, which are those? S0, S1 is there, okay, completed. Now the inputs over. Now the, what is the output here? That is to be written with the help of the keyword as the wire. That is, there we written the inputs actually. There we written the inputs to the wire, but we are writing the exactly opposite with the wire toward the output here. Output, that's the out. That's the out. Then we'll write the instantiated that model, okay, 4:1 MUX as the MUX. That one we call them, okay, that what we have written there, this one is the 4:1 MUX. ನಾನು ಹಿಂಗೆ ಬರ್ದೀನಿ, ಅದೇ ಕಾಲ್ ಮಾಡ್ಬೇಕಿಲ್ಲಿ, ಓಕೆ, ಅದನ್ನೇ ಕಾಲ್ ಮಾಡ್ಬೇಕಿಲ್ಲಿ. ಹೆಂಗ್ ಬರ್ತಿದೆ, ನಾನು ಇಲ್ಲಿ ಬೇರೆ ತರ ಬರ್ತೀನಿ, ನಾನು ಇಲ್ಲಿ ಬೇರೆ ತರ ಬರಕ್ ಆಗಲ್ಲ. ಸೇಮ್ ಅದು ಹೆಂಗದ ಹಂಗೆ ಬರಬೇಕು. 4:4_1_ MUX. ನೀವು ಏನ್ ನೇಮ್ ಕೊಟ್ಟಿರ್ತೀರಿ ಅಲ್ಲಿ ಪ್ರೋಗ್ರಾಮ್ಗೆ, ಅದೇ ನೇಮ್ ನಿಂದ ಕಾಲ್ ಮಾಡ್ಬೇಕಿಲ್ಲಿ, ಓಕೆ. Then the with the give this one as this instantiation, okay, that is the input output combination I have to send out as the first. Then inputs are, what are those? I0, I1, I2, I3, I4. I0, I1, I2, I3 and I4. Okay, then I have to start beginning, okay, I have to start the giving the inputs combination now. I have to check the, easily it can take the values, default values as the first input combination. First input combination it can take. But if you want to take give the set of numbers or set inputs, set of inputs as the stimulus, you can send with the help of what the block, okay, that's the block name. Let's start with the initial ಬರ್ದ್ಮೇಲೆ begin ಬರಬೇಕು, ಅಲ್ಲಿ ಮತ್ತೆ end ಬರಬೇಕು ಕಂಪಲ್ಸರಿ. ಇನಿಷಿಯಲ್ ಆದ್ಮೇಲೆ begin end ಕಂಪಲ್ಸರಿ ಬರಬೇಕು, ಓಕೆ. ಇನಿಷಿಯಲ್ ಆದ್ಮೇಲೆ begin end ಕಂಪಲ್ಸರಿ ಮಾಡಬೇಕು. Okay, initially I am sending the inputs, okay, that the output should be here like this only, okay. I am here, okay, just I0 as the 1, I0 as the 1, I1 as the 0 and the I2 as the 1 and the I3 as the 0, I3 as the 0. For this purpose I have to display with the inputs combination. How to done? Ampersand, sorry, dollar display with the I0 combination. I0 as the I0 to the what the binary value %b. Similarly I can send the value as the I1 as the %b, I2 as the %b and the I3 as the %b. Then I can send the value as the I0, I1, I2, I3. Okay, this is what the inputs combination I am sending here. For the value with the select lens should be what the for, and also I have to send the select lens also here. I have to send the select lens here. The select lens combination as the S0, equals to 0, S1 equals to S0 equals to 0, S1 equals to 0. 0, 0 combination I have to send here. 0, 0 combination. Similarly, write the remaining 4 combinations also. Write it. Similarly, write it remaining combination as the S0 as the 1, 0, S1 as the 1. Similarly, for the S0 as the 1, 0, 0, 0, 0, 1, 1, 0, 1, 1 combination, you have to send that one. Okay. Very remaining combination just to write, okay. S0 is another same copy ಮಾಡ್ಕೊರಿ line of piece of code, just to change the S0 and S1. ಇದು 0, 0 ಇರ್ತದ, ಅಲ್ಲಿ 0, 1 ಬರೀರಿ. ನೆಕ್ಸ್ಟ್ ಸೇಮ್ ಲೈನ್ ಬರೀರಿ, ಇದನ್ನು ಸೇಮ್ ಬರ್ದು 0, 0, 0, 1, 1, 0, 1, 1 ಕಾಂಬಿನೇಷನ್ ಬರೀರಿ. Okay, then the output would be what here? The I1 equals to 0, I2 I0 equals to 0, I1 equals to I0 equals to output on ಬರೀಬೇಕು. Okay, after the is execution of the my program. Okay, after the execution of my program, I will get the output here. What is the output combination? I naught equals to 1, I1 equals to 0. Similarly, for the I2 equals to 1, I3 equals to 0. Okay, then the S0 and the S1. S0 and S1, then the output would be what here? The I0. Similarly, for this combination 0, 1, 1 output is what? The I1. 1, 0 output is what? The I2. 1, 1 combination, I can have the output as the I3. This is what the writing of the program for the 4:1 MUX in the verilog HDL with the stimulus also. Definitely they will ask in the examination. This is the frequently asked question. Each and every exam they will ask this question many times. That's what I repeated this question. If you know the verilog code for writing a one program, one combination logic circuits, one digital system, easily you can identify it. Also, even you can also write one also. If I go with the half adder, then definitely you can, based on this only, we can write the program for the half adder also. Similarly, you can write the full adder also. Similarly, you can write the SR latch and also flip-flops also while referring this one only. Okay, they will be asking in the examination 4:1 MUX ಕೇಳಬಹುದು, ಆಮೇಲೆ full adder ಕೇಳಬಹುದು, ಆಮೇಲೆ ಕ್ಯಾರಿ ಲುಕ್ ಐಡಿ ಆರ್ಡರ್ ಕೇಳಬಹುದು, ಆಮೇಲೆ ಕ್ಯಾರಿ ಯಾವುದು ಕೌಂಟರ್ ಕೇಳಬಹುದು. ಈ ಕ್ಯಾನ್ ಆಸ್ಕ್ four input parallel adder, you can also ask. Similarly, you should know the digital system first, designing of the digital system with the basic logic gates. Thereafter, you can write the program easily. Okay, I hope you all come to know the. If you have any doubts regarding this writing of the program, if you know the one programming writing for any one combination logic circuits, you can write the remaining. I have the 4 to 5 combination logic circuits, so that you need to write the programming like this only. Okay, and now I'll start to go with the 4:1. Sorry, that full adder, 4-bit full adder.